And welcome to part 4, guys. So for number 17, they want us to rationalize the denominator of this fraction here. And when they say rationalize the denominator, they mean change the surd on the bottom half into a whole number. Now guys, there's actually a little hack over here. You could actually put this all in your calculator, and when you do so, you'll get the direct answer. Now unfortunately, you need to show your working, otherwise you can't do that. But that's like a little safeguard, so you know what kind of result you should be getting. Now to rationalize this easily, you always got times up and down by what the bottom is. In this case, we got times up and down by root 2 over root 2. Now what happens when we do this? Well, on the top half, you can have root 2 times both of these terms. 6 times root 2 is 6 root 2. And then root 10 times root 2 is just root 20. Alright, so far so good. Now all over, and when you do root 2 times root 2, when you times two of the same surds, you just get a whole version of it, so just a whole 2. You could also write root 4, but we know what square root 4 is. It's 2 anyway. Now it looks like we're almost there. Now what we're going to do, we're going to go ahead and try and tidy this up, yeah? So first things first, I would firstly try and simplify root 20. Now to break down root 20, what you could do is use the prime factorization tree. That is, just put 2 legs coming down and put 2 numbers that multiply to make 20. Well, we know root 20 can be broken down into root 2 and root 10. And then root 10 can be broken down into root 2 and root 5. Now, that's really it. And at this stage, you just collect all the roots. So what I always do, I circle the last legs and I say to myself, all right, root 2 and a root 2 gives you a whole 2. And you're left with a root 5. And that's what square root 20 is the same as. And by the way, I'm not 100% sure, but you can probably get away just writing root 20 in your calculator and it will give you this answer as well. Now let's put this all back into the final equation. So updating our equation over here, we got 6 root 2 plus 2 root 5 all over 2. And well, if you're dividing both of these by 2, 6 over 2 is 3, so you get 3 root 2 plus, and then 2 root 5 over 2 is just root 5. 2's cancel out. And that's it, guys. This is your final answer. Alright, number 18. So a particle moves along a straight line. The fixed point O lies on this line. The displacement, in other words, the distance or vector distance of the particle from this origin at time t seconds, where t is going to be 1 or more, is s meters. So we're saying here that it's so far traveled s meters after some period of time, where this equation can be modeled by this. So the displacement equals 3 plus 1 over t. At time t seconds, the velocity of the particle is v meters per second. Find an expression of v in terms of t. Alright, so for this kind of question, all you're going to have to do now is literally differentiate s and you get v. So if you guys are not sure, this is the process, yeah? You have a displacement s. If you differentiate respect to time, you're going to get velocity. And if you differentiate velocity respect to time, you get acceleration. This is kind of like a typical physics model, but we use this in differentiation as well. Now, the main idea is, how do we differentiate this equation? Well, you can't differentiate 1 over t like that because you need to change it to index form. Now, we always rewrite s, in this case, as 3 plus. Well, 1 over t is just the same as t to the negative 1. If you guys are not sure, when something's to the power of a negative, it means it's reciprocal. So t to negative 1 is 1 over t. If it was t to negative 2, it would be 1 over t squared, and so on. So in this case, we're going to differentiate this equation here. To differentiate, we write ds over dt equals, and then differentiate a constant, you get 0. Differentiate t to negative 1, well, you drop negative 1 down, so it'll be minus t, and subtract the power by 1. Now be careful, guys. A lot of people might be tempted to write 0. But minus 1 take away 1 is actually minus 2, okay? And therefore, this is your answer. So the answer is minus t to the negative 2. Now, they might be picky. They might want you to rewrite this in this kind of notation, yeah? So t to negative 2 is the same as 1 over t squared. Either way, I think both is fine. And that's it, guys. This is your answer. Now, B, find the acceleration of the particle at time 6 seconds. Alright, so to find the acceleration, we have to differentiate one more time. So let's differentiate this equation here, yeah? So we can say, alright, so yeah, let's give this a name. So this was velocity. So we say dv over dt, which will give us our acceleration now. So differentiating this one, you drop minus 2 down, you get plus 2t. Subtract this power by 1, you get minus 3. Okay, and again, this can be rewritten as 2 over t cubed. Now they're saying find the acceleration of the particle at 6 seconds. So in other words, in t6. So we say the acceleration is 2 over 6 cubed. And put that in a calculator, guys, and you should get 2 over 216. And this is the same as 1 over 108. So yeah, I think this should be your final answer, and that's it. And as always, guys, if you're really enjoying these videos, please give me a like so that way YouTube will configure its algorithms to put my videos on the search bar. And if you want to see more of this, share it with your friends and subscribe. Alright, number 19. So the diagram shows a container made from a cylinder and a cone. So here's our cylinder and here's our cone. The container has a vertical axis of symmetry. So I think when they say that, all they want to say is that if you just put like a needle or something in, or a line, it's like symmetrical around that. I don't know. That's what I personally understood from it. Now, looking at the shapes, we've got cylinder and a cone. The cylinder has a height of 20 and a radius of 15. And the cone has a height of 18 and also a base radius of 15. There are 9 liters of water in the container. Okay, so notice how they use liters here. What this is trying to say is that for every 1 liter, and we need to know this relationship, you get 1000 centimeter cubed as its equivalence, yeah? So this is actually an identical relationship. Okay, so I think that's kind of tricky. So they want us to know that 9 liters is therefore 9000 centimeter cubed. Okay, cool. So work out the height of the surface of the water in the container above the vertex of the cone. Okay, so the best way to understand how to solve this question is to firstly figure out what's the volume of both these shapes. Because we know there's 9 liters inside. It doesn't cover everything, but it goes up to some height. So if it helps, what I would do, I'm going to just put a little diagram here. So let's just imagine 9 liters goes up to here, yeah? And it's covering this entire area. And we know that this is some height that they want us to work out. So this could be the height of the water in the container, okay? If we can figure out what that volume of water is, then we're good. And the best way to do that, figure out the volume of both this shape and then start subtracting until we get the answer. So let's do it like that. Now, first things first, what is the volume of a cone and volume of a cylinder? So in this case, the volume of the cylinder, so I'm just going to label this part here, is pi r squared h, where r is the radius, h is the height. And because we've got everything, it's just pi times 15 squared. So 15 squared times your height of 20. And this simplifies to 4500 pi. So always just work out in pi form, yeah? Try not to simplify yet. And as for the volume of the cone, this one's literally also given, and it's a third pi r squared h. So it's actually 1/3 of the cylinder. Now the only difference here is that the radius is actually the same, but the height is different. So the value is going to be 1/3 times pi times 15 squared times 18, and this should give us 1350 pi. Again, always leave your answers in pi form, yeah? It's more accurate and it's just easier to look at. Now, what's next? Okay, so now with these volumes, and we know the fact that there is 9 liters of water in the container, which by the way, guys, is the same as 9000 centimeter cube, so that is 9 liters. What I would do is firstly, I would subtract 9000 away from the cone part and see how much water is actually left. So we can say that 9000 minus 1350 pi should give us an amount of 4758.8 centimeter cube left. So that's how much water is left, and that's going to be the amount left in the upper part, yeah? So this region here. So this is how much water is left. Now, at this stage, we're going to ask ourselves, okay, how much percentage of this water is occupied in this cylinder here? Because if we can work out the percentage of it, then we can use that percentage to multiply against 20 to figure out how high the water actually was raised. So I always redraw these things, yeah? So I'm going to redraw the cylinder here in 2D form. Let's say this is the area that's currently occupied. That's equal to this value here. And we know that the container itself has an area of a volume of 4500 pi. So 4500 pi. Now to figure out how much water is actually occupying this container, we just got to divide them. So it's going to be, therefore, 4758.8 over 4,500 pi. And this should give us some kind of small number. If you do it correctly, you should get an answer about 0.3366 and so on. So what it's trying to say here is that this water is occupying about 33.66% of its height. So all we do now, using the scale factor, we're going to multiply against 20 and find out how high it is. So taking this of 20, so we say therefore that amount times 20 should give us about 6.73 centimeters, guys. So that's how high the water was raised in this pod container. So this is 6.73. Therefore, the whole height, so HW, will be this amount plus 18. So therefore, we say the height of the water was 18 plus 6.73 centimeters. And again, they wanted to 3 significant figures, guys. So that's about 24.7 centimeters. And that's it. Whew, man, this question was a bit tricky, wasn't it? Let me know your thoughts about this question so far, guys. You know, let me know if you got any doubts on any part of the calculation. It is kind of intense, I'm not gonna lie. But anyway, let's move on. All right, number 20. So there are 9 counters in a bag. There is a number on each counter. All right, so we've got 9 counters here. 3 of them are 2s and 6 and the rest of them are 5. So that's 6 of them. Okay, oh thank God, so it's not a mixture of numbers. Now Lev takes at random 3 counters from the bag. He adds together the numbers on his 3 counters to get his total. Calculate the probability that his total is an odd number. Okay, so for these kind of questions, let's just do what they say, yeah? And pick 3 counters and see all possible combinations to get odd, yeah? Now, if I just start from the top, to get an odd number, we should always pick 2 evens and an odd. Or 2 odds and an even. I think. Nope. 2 evens and an odd. So, for example, our combinations could be, you get 2, another 2, and then that makes 4, and a 5, and that makes 9. That's an odd number. You could also do 5, 5, 5. Yep, that's an odd number. What else do we have? 2, 5, that's even, that doesn't count. So we keep testing it. 2, 2, 2, that's even. Yeah, I think that's it. There's only 2 possibilities. Perfect. Now all you want to do from these possibilities, stick in a P sign for probability and ask yourself, what is the probability of taking a 2 first? Well, let's do it over here, yeah? I'm going to rub this out quickly. So probability of taking the 2 first is going to be, well, we've got 9 counters, you've got 3 2s first, so it'll be 3 out of 9. Now probability of taking the second 2, well, we've now got 8 counters left, and 2's already been taken, so you've got 2 left. And then now you've got 7 counters. What's the probability of taking a 5? Well, you got 6 of them. So this would be the first set, and then you can easily work out after. And you do the same for 5s. So again, we ask ourselves, what is the probability of taking a 5 first? So you got 9 counters, and you got 6 of them. So 6 out of 9. Probability of taking another 5 is going to be 5 out of 8. And probability of taking, what is it? The third 5 would be 4 out of 7. Okay, because that's how many you got left. And yeah, that's it, guys. We just work them out and we get a result. So if you work them out independently, this would be 1 out of 14. And the bottom one would be 5 out of 21. So just use your calculator, guys, yeah? So now we ask ourselves, is there any other probabilities we can do? Yes, there is actually. We can look at the first one and realize we can do this in different order. For example, we could have picked a 5 first and then a 2 and a 2. Or we could have picked a 5 in the middle. So 2 first, a 5, then a 2. So actually, and it turns out if you do in a different order, you're going to get the same result, which is also 1 out of 14. And again, 1 out of 14, because you got pretty much the same set. So essentially, you got 4 probabilities to work out with. It doesn't work for this one because you can pick 5 in any order and the output is the same. In this case, you have a different order. And yeah, that's it, guys. So now you got all your results. We just want to add them all up. Now, if you add up all of these 4 probabilities, you got 1/14 plus 5 21s plus another 14th and another 14th. You should get a total probability of 19/42. And yeah, that's it, guys. This is your answer. And here we go, guys. Number 21. And this is the last question of the paper. So let's do this. So it says that f is the function such that fx equals 3 minus 2x. All right, so this is your function defined. Find f at the point minus 4. So in other words, when x equals minus 4. So let's go ahead and do it. So all they want us to do here is replace x with minus 4. So it's going to be 3 take away 2 times minus 4. And if you put this all in the calculator, you're going to get an 11. And that's it. That's A done. B. Express the inverse function f to the negative 1 in the form of f to the negative 1x. Yeah, I never really understand why they write like that. But all they're saying here is just compute the inverse function, yeah, of f. Now, to get the inverse function, there's a nice little trick to do this. I always start like this. I say, okay, let x equals fy, so you do things in reverse. And essentially, you replace fx with fy, so all the x's become y. So replacing this with y, you get 3 minus 2y. Now, all you want to do here is literally rearrange this to make y the subject. So again, because all of this equals x, in other words equals x, I'm just going to deal with this part. So 3 minus 2y equals x. I'm going to rearrange to make y the subject, and then you're done. So to do it step by step, I would firstly minus 3 across. So it would be minus 2y equals x minus 3. And then I'll divide this by minus 2 to get y on its own. So y equals x over 3 minus 2. And if this result looks kind of weird, you can tidy up by just flipping the order. So this is the same as 3 take away x over plus 2. That's it. So the negative literally just flips the order. And that's your answer. 3 minus x over 2. I'm sure this is also right because it's equivalent. But it's better to get something that looks nicer. Alright, so guys, next part. So g is the function such that gx equals x squared minus 5. Alright, so that's a new function. We had fx, now we got gx. Solve the equation, gfx equals ffx. Man, show clear algebraic working. Alright, what does this mean? So gfx, so this means that f has gone inside g. In other words, this function, this x squared, all this x is being replaced with this entire f function. So we say, alright, that's your f, that's your g. So g fx is basically, instead of x squared, it's going to be the f function, 3 minus 2x. Now it's squared, take away 5. As for ffx, well, that's, as I say, that's f in f. So you're putting this function inside the x. So let's copy out 3 minus 2 part for a second, yeah? This is 3 minus 2, and inside the x, you're going to put 3 minus 2x. Yeah, it's a bit weird, but that's how it is, yeah? And now apparently, both of them are equal, so we make them equate to each other. So before I equate them, how about we go ahead and simplify the expressions, yeah? So the top half, like this is a double bracket. So this is essentially 3 minus 2x times 3 minus 2x, then take away 5, okay? And evaluating this isn't too bad. So we just do 3 times 3, 3 times minus 2x, minus 2x times 3, and minus 2x times minus 2x. And then take away 5. And doing that, well, you're going to get a 9. 3 times minus 2x is minus 6x. And you get another minus 6x, so it's minus 12x. Minus 2x times minus 2x is plus 4x squared. And then you subtract 5. And then just tidying up the order, I always do the quadratic first, yeah? So 4x squared goes first, minus 12x, and then 9 take away 5 is plus 4. That's it. So that's the gfx tidied up. As for the other one, ffx, well, do the same thing, guys, yeah? So for ffx, you just expand in the bracket. It'll be 3 take away, well, you got minus 2 times 3 is minus 6. Minus 2 times minus 2x is plus 4x. And tidying this up, again, I do this in order, so 4x goes first. 3 take away 6 is minus 3. And that's the other one done. And lastly, again, according to the equation, it says solve the equation when they're equal to each other. So let's equate the quadratic with the linear term. We're going to get 4x squared minus 12x plus 4 equals 4x minus 3. And now because you're solving a quadratic equation, you're going to move everything to the left side. So combine terms and make it equal to 0. Okay, so make this equal to 0. We're going to minus 4x and add 3 across. If you do that, you're going to have minus 12x, take away 4x is minus 16x, plus 4 add 3 is plus 7. Alright, so it looks to me like we're almost getting to the end here, yeah? Now, what can we do? So, if we solve this quadratic, I think we're done actually. Is that what we're done? Yes, we're done. Alright, to solve this, I would just use the quadratic formula because it's quick and easy. Now, to use the quadratic formula, again, just find your A, B's, and C's. 4 is your A, minus 16 is your B, and plus 7 is your C. And the quadratic formula, guys, is always x equals minus b plus minus square root of b squared minus 4ac all over 2a. And yeah, putting all of this in. So let's see if I can do this in that space. X is going to equal minus b, so b plus 16 plus minus square root 16 squared. I'm not going to bother doing that. Minus 16 squared minus 4 times a times c. So 4, 4, 7. Again, wrap them in a bracket, yeah? All over 2 times 4, which is 8. So now put everything in your calculator. For the plus minus bit, first you write a plus sign because you can't do this symbol. Get an answer and then repeat it with a minus sign. Or just go back and change the sign to a minus. And when you do it, you'll get 2 answers. The first answer will be 7 over 2. And the second answer should be 1 over 2. So in other words, 3.5 or 0.5. And yeah, guys, we are done. And yeah, thank you guys for tuning into my video. I hope these questions have been helpful. If they have, please leave a comment and suggest me any new papers you want to do. After this paper, I'll probably just work on a more recent papers. But if you guys got anything else you want me to help you with, again, let me know in the comments. And yeah, we'll keep in touch, guys. But other than that, stay blessed, stay safe from the coronavirus, and I shall see you guys next time. Ciao. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications. And if you want, you can do personalize or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.